Hey guys, good morning and happy Monday. So we have Halloween quickly approaching this week. So the first thing that I wanted to do as kind of a warm up introduction activity, we're going to talk about baggage. Now, baggage. Everyone has it. So on the piece of paper or sticky note that I give you on your desk, I want you to think about something that baggage you might carry. So, some days we might say, no one cares about me. I'm going to die alone. I'll never find someone to help me out and go through life with. I hate my life. We say these things, maybe not necessarily out loud, but we say them in our minds. We might say it to someone else. But we would call this emotional baggage. Now, you might say to yourself right now, Mr. Host, what are you talking about? So let's read a little more about it. Now, everyone has baggage, but how you carry it is what matters. Some people seem like they have it all. They're happy, they have a great relationship or marriage. Maybe they have a great job that they love. But no matter how wonderful you think that person's life is, everyone has insecurities or doubt pop up from time to time. Nobody is perfect. Everyone has baggage in their life. Some may just have a little more than others. Baggage does not only come from just a bad relationship. It can come from an argument with a friend, a bad memory from school, maybe a rough childhood. You might not even realize that some of your personality traits were shaped from this baggage. Now, on the back side of the paper, without writing your name on it, I want you to write one thing that you have been struggling with, something that you have been carrying, some sort of baggage that has been burdening you or weighing you down, something that you have been stressed about, something you have been sad about. Now, the whole purpose of this, we're not going to write our names on it, but it's to show others in the class. We're going to mix them up and give them back to someone. Show others in the class that everyone is dealing with something at one point and another in our lives. Okay, so pause the video, take a moment, write something down, and hand it to me. All right, great. So the next thing we are going to do, we're just going to do a little bit of review. Tomorrow we do have a quiz. That's why we're doing this. And it's just going through some of. So the first thing that we're going to go over during our review is map scale. Now, some people are still a little bit confused with this, and that's quite all right. So some people, when you think of a scale, automatically think of a weight scale. You get on a scale, you're like, whoa, I ate a lot at Thanksgiving dinner. I'm 10 pounds heavier. No. When we're talking about maps, or we're looking at maps, we are talking about how much distance is shown. So for example, this scale, 0 to 25 miles, this small line, if I were to take a ruler or take my finger and measure on this map, okay, I know that from 0 to 0.25 of a mile is from here. So 0.25, half, 75, full mile, right down Tyrone Street. Okay? So a scale on this map is showing 0 to 200 miles. So that can tell me, okay, from here to here, I know that's 100 miles. I'm going to measure from here to here. It's about 100 miles. And then if we go to the even smaller scale map, just showing a bunch of states, just one state and a city, one state, bunch of states on the East Coast, from 0 to 400 miles. So tip of Florida to probably about here in Georgia is like 400 miles. And from here to here, probably another 4, so 800. And then from here to here, about another 400 miles from North Carolina to Pennsylvania. Okay, so scale represents distance, how far away or close something is on a map. Political and physical maps, you're not going to know, I'm not going to ask you this, but people who make maps are called cartographers. We know this, we talked about it before, but just know, political maps show boundaries, countries, states, capitals, etc. Physical maps show landforms, mountains, rivers, lakes, ocean, seas, things like that. Map projections, just know this word. So distort. Distort means to change shapes, areas, distances, right? So remember I was calling the Hamzaline projection the saggy diaper. Now it is distorting the way the world looks because it's trying to stretch things out. So it's stretching over here and it's stretching over here. Okay, so that's called distortion. Now, you will need to know this. So thematic maps, theme, a theme or topic. Think of that. I like to think of a theme of a movie. What's it going to be about? Okay, so what's this map going to be about? U.S. alternative energy. Okay, so instead of using fossil fuels like gas and oil, things like that, we're going to use wind farms and hydropower and solar power. So it's showing you where these alternative energy sources are located. Okay, so you can kind of see there's not many in the middle Midwest of our country, but there's some on the eastern side and the western side, northwest, for being more specific. Okay, so that is thematic maps. This is important. So, Earth's rotation and revolution from the start. Rotation occurs what? Daily, day and night. Rotation, day and night. We have it every day. But the revolution, the Revolutionary War was not fought overnight. It takes a long time. So revolution, long time, 365 days, a full year, and we go through 4 seasons in a revolution. In a rotation, day and night. Now, going to the revolution pattern. So because our Earth is on its axis, right? It's not, our Earth doesn't sit straight up and down. You can see how it has a tilt. See the tilt? So let's just say summer, right before school started. We're in summer. We're enjoying the nice summer days with our friends outside. We are closest to the sun. The northern hemisphere is closest to the sun. We're getting its direct sunlight rays. You can see it's hitting right here. This is where we live. It is hitting us very close. Now, on the opposite, imagine if there was a line here. This bottom half of our Earth, or the southern hemisphere, is not getting a lot of sunlight, which gives them winter. Think of it flip-flop. Okay? So we would call this a summer solstice. And in a solstice, we either have the longest days. So in the summer, it's daylight for a long time. That's because the sun is more direct. It is shining more directly on our northern hemisphere because that's where we live. Now, when we get to the equinox, day and nighttime are equal. Equinox, equal. Equinox, equal. We have equal amount of darkness and daytime. But when we get to summer in the and when we get to winter in the revolution, we are receiving less sunlight. We are getting indirect sunlight, which causes us to have winter. Then as we're going through our revolution still, closer and closer and closer back to that nice summer season, we are getting more sunlight. Again, spring and fall, what we are in are now, what we're in currently, have equal amounts of sunlight. Equal. Okay? Equinox, equal, solstice, short in winter, long in summer, in terms of sunlight. Earth's complex structure. So this is all I want you guys to really know. I need you to know the crust is what we walk on every day. Mantle, outer core, inner core. I'm not going to ask you what types of elements or iron or things like that are in there. I just want you to know the layers. Crust, mantle, outer core, inner core. And remember, if we can't drill down this deep to the cores, how are we supposed to know what's in there? Well, our Earth burps. Don't forget, it burps. It burps in volcanic eruptions. So that stuff that's all the way down here, when a volcano erupts, it goes, and we can see the magma. We can see what's actually down here from our Earth spewing it out. It's throwing it up. Ew. Landforms. I might ask you about a couple, but just remember surface landforms. Landforms are things that we can see with our own eyes, different things on our Earth. Okay? For example, a plateau. Plateaus are weird. We know this. They are high and they are steep, but they are flat at the top. Also very important. I'm going to ask you to label the parts of the cycle. Now, the water cycle, the first thing that happens is evaporation. The water goes up because the sun heats up the ocean, or fresh water heats it up. Condensation holds it in like a big hug, and then precipitation drops it. Now, in terms of precipitation, it can rain, it can snow, it can sleet, and it can hail. That's all the forms of precipitation. And then runoff, all that water or whatever it may be is going back. The process restarts. It's just a restarting process. It's raining down into the mountains feed the rivers, it goes into a lake, it might go right back into the ocean. Now remember, salt water is a little bit hard. It takes a little bit longer for it to evaporate because it has a molecule of salt, 2 molecules of salt, and 1 molecule of water. So the water molecule and the salt molecule are fighting to break apart. So once that happens, the water goes up and the salt goes to the bottom. Remember, climate. Climate is over a period of time. The average condition of an atmosphere over a long period of time. So our seasons. Right? I would write this down. Climate equal seasons. That's how you can remember. Climate's not, it's not day to day. Weather is day to day. Sorry about that, guys. So back to it. Weather, again, day to day. Climate is over the seasons. We didn't really talk about climate regions, so we're going to skip right over that. Something new that's going to be on our quiz. Now, resources. All I want you guys to remember is raw materials, non-renewable resources, and renewable resources. Raw materials are basically anything that has not been made into something yet. For example, this is one they have down here, iron. Iron's from the ground, it's mined, and then it's created to use things like steel and automobiles and buildings. Now, non-renewable resources are resources that are limited. Break it down. Non-renew. It's not able to be renewed. It's limited. It has a set amount. For example, oil, coal, gold, silver, copper, all those mineral resources, precious resources. Renewable resources will never run out. Like wind, water, solar, or geothermal are all renewable. Okay? So this is kind of goofy, but this will help you remember raw resources. So here's a piece of wood, fresh cut piece of wood. It is raw. It has not been created into anything yet. Can't do anything with this piece of wood, but it has to go through a process. After it goes through the process, we have a product. It's a table. It's a beautiful table from that raw resource. Okay. Just remember Earth's rotation revolution, water cycle, equinox, when they are equal, fall and spring, and solstice. So summer solstice, we have a lot of sunlight because we're getting more direct sunlight from the sun because of the axis, and then winter, we have short days because we are farther away from the sun. All right, guys. So I will hand you out a review sheet. I will also put it on the classroom. Thank you.